So the following data relates to the percentage of failures in the 10th standard examination. They have given us the age of candidates and the percentage of failure according to the age. So what are we supposed to find? Find whether there is any correlation between age and failure in the examination and interpret the results by finding the probable error. So they have clearly asked us to find the probable error. So firstly, to find the probable error, we are supposed to find out the correlation coefficient. That is R value we have to find. Okay, so what is that R value? Computation of Carl-Pearson's correlation coefficient, that is nothing but X and Y both are supposed to be taken from the question. Then solve this question by taking assumed mean. Okay, you can consider from the actual mean also, but assumed mean will be easier and it will be quick. We should take only R has 6 on. Okay, Akhila, I did not understand your question. Can you just rephrase it? By then we will complete this calculation. So dx is the value that we have got. The assumed mean that we have taken here is 17, and for x, and for y we have considered 43. So then we will get dx and dy. And then if we square them, you get dx square and dy square and dx into dy. Correct? And what are the 5 major totals that we are supposed to get? Sigma dx, sigma dy, sigma dx square, sigma dy square, sigma dx into dy. These are the 5 major totals that we are supposed to find to apply this in the formula and find the value of R. Now let us find the value of R. Formula is very important to be written in every problem. So n into sigma dx dy minus sigma dx into sigma dy whole divided by square root of n into sigma dx square minus sigma dx whole square multiplied with square root of n into sigma dy square minus sigma dy whole square. Okay. Now apply all the numbers. N is nothing but 9 numbers, that is 9 data which is given to us. Then n 9 into 88 minus 0 into minus 9 whole divided by square root of 9 into 60 minus 0 square, again multiplied with square root of 9 into 293 minus of minus 9 square. Okay. Now if you simplify this value, you will get the R value to be 0.6741. Okay, 0.6741. Now let us interpret the correlation coefficient using the timeline. Now in the timeline you have +1, you have -1, and then you have 0. So this value which comes between 0.25 and 0.75, so you can directly say that this value of correlation coefficient lies between 0.25 and 75. So it is moderate degree of positive correlation. The number is positive, so moderate degree of positive correlation. Okay, so we finished until here. Any doubts until here? Did you all understand that part? Any doubts? Okay. Now let us go on and calculate the value of probable error. Now for probable error, we require value of R and value of N. Now we already have found the value of R, which is 0.6741. So 0.6741 is the value of R, and the value of N is 9 as per the question. So let us apply that. Probable error is equal to 0.6745 into, this is a constant, 1 minus R square by square root of N. So 0.6745 into 1 minus R square is 0.6741 square whole divided by square root of 9. N is 9. Now, if you simplify this, you are going to get the probable error of 0.12265. Okay, so we found the value of R. We also know the value of probable error now. Now, let us do some analysis of the probable error to find out if R is significant or insignificant. Okay, now what is the actual thing that you're supposed to do? If you, this R should be more than 6 times the probable error. Okay, this R should be more than, that is 0.6741 should be more than 6 times, wait a second, should be more than 6 times the 0.12265. Now find the value. 0.6741 should be more than 6 into 0.12265. How much do you get? 0.12265 into 6. You get 0.7359. We get 0.7359. Now compare the R value 0.6741 and compare the 6 into PE that you have got. Which is higher? R is higher or 6 into PE is higher? Which value is more? 6 into PE, which means R is not significant. If 6 into PE is more, R is not significant. Okay. Suppose if R was more, then R is significant. Understood? Understood how to compare? You have to compare the value of R along with 6 times the value of PE. If 6 times the value of PE is more, R is insignificant. Okay. Insignificant, not significant are one and same. Fine. So here in this problem, R is not significant or R is insignificant. Everybody understood? Any part you want me to repeat it again? I want everyone to reply. Okay. So this completes our Carl-Pearson's correlation coefficient. Now, before going to Spearman's rank correlation coefficient, let us just revise what all we have learned under Carl-Pearson's correlation coefficient. Okay, so listen carefully. So, Carl-Pearson's correlation coefficient. In this, we have two major ways of solving the problem. One is through actual mean. Okay, one is through actual mean. The other one is through assumed mean. Assumed mean. Now, in actual mean, we will be considering the actual sigma x by n value or sigma y by n value. Okay, now sigma x by n value, sigma x by n or sigma y by n value will be considering. Now in the assumed mean, we will consider one of the value of x and one of the value of y to be as assumed mean. And then we will be calculating the sigma x square, we will be calculating the x square value we will be calculating the x square. Before x square, we have to calculate the deviations, that is dx or small x. In the case of, wait, let me rewrite it properly. In the case of actual mean, we will be calculating small x and small y. Small x is nothing but x minus x bar, and small y is nothing but y minus y bar. Okay. Now, in the assumed mean, we will be calculating dx, that is nothing but x minus assumed mean of x, and we'll be calculating dy, that is y minus assumed mean of y. Okay. And then coming to actual mean, we will be calculating small x square and small y square. And in the assumed mean, we'll be calculating dx square, and here we'll be calculating dy square. Okay. And finally, the important value that we want is x into y. We have to multiply small x into small y to get the values. And here in the assumed mean, we will be calculating the dx into dy. So what are the important totals that we require to calculate is firstly the deviations. Here first we will have to find out the x bar and y bar, and then deviations small x small y, then x square y square and xy. So if you do the summation of these, you will be able to get the totals. And coming to assumed mean, you will have to first find the assumed mean values and then find the deviation, that is sigma dx and sigma dy if you total them. And then you have to square the deviations. So dx square, if you add, it becomes sigma dx and sigma dy. And then finally sigma dx into dy. Fine. So these are the two major ways which we solved under Karl Pearson's correlation of coefficient. And then throughout Karl Pearson's correlation coefficient, the value of R is supposed to be analyzed using the timeline. In the timeline, if the number is positive, you take it as positive correlation. If the number is negative, you take it as negative correlation. And if the number lies between 0 to 0.25, it is called low degree positive correlation. And if the number is between 0.25 to 0.75, it is called moderate degree of correlation. And if it is more than 0.75 till 1, it is called as high degree of positive correlation. Similarly, on the other side, if you have the negative number and the negative number is between 0 and 0.25, it is called as low degree of negative correlation. And if it is between 0.25 to 0.75, it is called medium degree or moderate degree of negative correlation. And if it is more than 0.75 to -1, it is called as high degree of correlation, that is negative correlation. Okay, so we use this to do the analysis. Okay, once we do the analysis of this, then we will have to consider one more type of problems which we did, that is directly taking the data. Okay, in the problem we would have been given the data of x as well as y. Now in the problem, when they give you the data of x, x is called the independent data. Okay, x is called the independent data and y is called the dependent data. Now why is this called dependent? Because the values of y is dependent on x. Now even if you take this current problem here, there is a correlation between age and the percentage of failures. So age is an independent data. Age will not get influenced by anything. Okay, but percentage of failures can be influenced as per the age. Okay, people at at the age of 15, 16 might be more interested to study rather than when they are in 23 and 25. Okay, so this is a dependent data and x is the independent data. Okay, if the data is of a very simple form and it is in the values of 1 2 3 4, okay, if it's in the single digit values or maximum of double digit values, in such scenario you can directly use the data and solve or find out the value of uh, the R, that is correlation coefficient. Okay, how do we do that? We will consider the value of X and value of Y, and then we will go by the assumed mean method. So in the assumed mean method, you can consider one assumed mean and find the deviations. Directly what you will be doing is you will just find X square, you will find Y square, you will find X into Y. X into Y is the same data. Since it is very small data, we will not even go through the deviations. Okay, so we will go with X square, Y square and X into Y, and then find the value of R. Okay, so these are the three methods, that is actual mean, assumed mean and the direct data calculation method. These were the three important methods which we solved here, right? So this is your Karl-Pearson's correlation of coefficient. And then we learned the probable error. Now in probable error, we will have to first find out the limits of the R. Now why are we finding limits of the R? It will give us a range saying your data or your number will be between this number and this number. So when we have the limits of the data, we will be able to understand where we are going wrong and what has to be done right. So to find the limits, what is the formula to find the limits? First you have to find R, or if R would be given, then R plus PE will be the upper limit and R minus PE will be the lower limit of the data. Okay, so that is one thing which you are supposed to learn. Then after that, the other important thing in the calculation of PE will be the significance of PE. How do you understand if the correlation coefficient is significant or it is not significant? You have to find out the value of R, find the value of PE, and then compare both the values. But here you have to make sure if the value of R is more than 6 times the PE, then R is significant. Okay, R has a better value in this case. But if R is not more, okay, if R is less than 6 times the PE, then R is not significant, which means R is insignificant, like how we checked in this case. Now here, by doing this, R will not hold any value or R value will not make any sense for that particular data. Clear? Then they will go for the further calculations and solve, which is not part of your syllabus. Okay, so this is completely Karl-Pearson's correlation coefficient, which has been revised. Any doubts until here? Now check your classwork, go back, check every problem. I'll give you 2 minutes. Anywhere, any part of the problem you have doubt, you can ask it now only. Okay, so check your classwork. One more thing, what I saw from your test papers are many of you have got confused with few of the values and have overwritten. I've been telling even from the previous semesters, when it comes to maths and accounts, please do not overwrite any values. Once you write, leave it and start the fresh problem. Or if at all you have whitener, you can use it. Don't scratch and write, or don't write over the same numbers. Okay, the more clearly and neatly you write in your test papers or in your exam papers, you will be scoring full marks. Full marks will be given because you have written it neatly. But there are chances of cutting down the marks if the answer is not clear and if the answer is not neatly written. And in correlation, any point of time, if you have not written the conclusions, the marks will be cut. At least 1 mark to 2 marks will be cut if the conclusion is not written, because just the value of correlation does not mean anything. You should know how to interpret the value. Fine. Any doubts until here? Carl Pearson's correlation coefficient. Okay, Bhavna says no doubt. Okay, no doubts. I want everyone to reply quickly so that we can go to the next concept. Okay. Good. So what you're supposed to do is, including today's class, after the class I'll be sending these notes anyways. Okay, until Carl Pearson's correlation coefficient, that is until this problem, until this R is insignificant, I want all of you to complete your notes and send it in the PDF form to me from starting. Starting is from your first chapter. Okay, until today, all that, just scan and send it to me before 5 p.m. today. Okay, so I'll just put a message in the group also. Now let us go on further and learn the next concept, Spearman's rank correlation coefficient. Okay, so here in 1904, a British psychologist, Charles Edward Spearman, has developed this method. Okay, here what is he trying to do? He calculate coefficient of correlation between two sets of variables which are not quantifiable but ranked. You cannot quantify them, you cannot write them with numbers, but you can rank them. You can say this is first, this is second, this is third, like that, on the basis of some qualitative characteristics. Here we are not considering the numbers here, but we are considering the qualitative characteristics, maybe a fairness of a person. Okay, or you can talk about their quality as how honest a person is, how intelligent a person is, how beautiful is his or her voice. Now all these you cannot quantify it. Okay, you cannot get it in the numbers, you cannot get the intelligence in the numbers, right? You cannot get the beauty into the numbers. So such data we are going to take and rank them. Okay, now they would have given some codifications, and from that codifications the data would be derived, and we will be finding the relation between such qualitative characteristics. And this method will measure the correlation coefficient between the abstract characteristics like beauty, intelligence, singing, dancing, etc. Okay, now even if you are judging an event of dancing, let's say, now in that scenario you will have certain criteria, maybe the postures that is used in dancing, what is the form of dancing that they are doing, how are their expressions, what are the dance movements, is it in accordance with the song that is being played. You have certain criteria which you'll be considering. Only then you'll be able to give marks for that quantifying dance that is there. Okay, the qualitative characteristics is being converted to quantitative. So if you have such data, then we'll be using Spearman's rank correlation coefficient and we'll be using this formula to calculate. So R is equal to 1 minus 6 sigma d square whole divided by n cube minus n. So what does it stands for? R. Here it is capital R. Do not get confused. Carl Pearson's correlation is small r. Spearman's rank correlation. Here rank is very important. Rank correlation is capital R. Then D is nothing but difference between ranks. Then N is number of pairs of items. Okay, and the value of R again will range between +1 and -1, like how we had for correlation coefficient small r. In a similar manner, we are going to get the capital R also in the +or-1 values. And again, here we'll have 3 situations to learn. That is, in rank correlation, we may come across 3 situations: when ranks are not given, when ranks are given, and when ranks are tied up. Tied up means you'll have repeated ranks. 2 or 3 will be having first rank, 3 or 4 will have second rank, again 2 or 3 will have third rank. Like this, if the ranks are repeated, how do we solve the problem? And when the ranks are given, how do we solve? And when the ranks are not given, how do we solve it? Okay, so this is what we will be having under Spearman's rank correlation. Then first we will learn calculation of R when the ranks are not given. This will be the first scenario. Okay, now before me starting this first scenario, did you all understand the concept of Spearman's rank correlation? Yes? Any doubts in that? Compulsory 6 marks and 14 marks will come from this chapter, overall correlation and regression. You will have more than 2-3 problems which will come from this chapter. This chapter is very, very important for the examination. So concentrate and learn all the questions. They are very easy if you understand the question and if you know which formula to apply in each of the scenario. Fine. So can I start with this first scenario? Guys, reply. Okay. Now, first scenario is calculation of R. R is, capital R is Spearman's rank correlation coefficient. And when ranks are not given, okay, they will not give you the rank 1, 2, 3, 4 is not given. So when actual data are given and rank correlation is to be computed, first we have to assign ranks to the given series individually. Now they have given us the data. Let's take, this is the data. Now for this, we have to individually assign the rank, and then ranks can be assigned either in ascending order or descending order depending upon the magnitude of given variables. Okay, depending upon the magnitude of given variables, we are supposed to arrange the ranks in ascending order or descending order. Then after assigning the ranks in respective series, D, that is capital D, the difference between the corresponding ranks in two series and D square are computed. Then applying the given above formula, correlation coefficient is compound. So let us directly get into the problem here to understand the process which is explained. So first, calculate Spearman's correlation of rank correlation for the following data. And they have given the values of X and the values of Y. Now, how much data do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 data is given to us. for both x as well as y. Okay, now coming to the table calculation, we will first write down the value of x and y, and we will find the ranks for R1 as well as R2. Okay, now how do we find ranks? Now to find ranks, you just have to arrange, or you just have to give ranks as per ascending or descending order. Okay, now here we have started it from descending order, highest number being first, and then the next lowest will be given. Now out of all this data here, 98 is the highest, so I am going to give first rank to 98. Then after 98, 95 is the next highest, so second rank. Then after that I have 81, which is the third highest. After 81, 75. After 75, something in 60s, yeah, 61. Then after 61, 59. Then 55. Then 57. So this is how we assign the ranks for the data. Highest number, give the first rank. The lowest number will get the lowest rank. Now let us assign the ranks for data y. Now here, out of this, the highest number is 47, so first rank. The next highest is 45, second rank. Next highest is 40, that is third rank. Then after 40, you have 39, fourth rank. Then 37 is the fifth rank. Then you have 32, 6, 30 is seventh rank, and 25 is eighth rank. Okay, like how you give, like how we give marks for you and choose the rank for you. In the similar case, we are also ranking from the highest number to the lowest number. Okay, these are the numbers which are R1 for x and R2 for y. If you see, the same ranks that has been written here. Okay, so this is how you assign the ranks for x as well as for y. Okay, the next step is finding the difference between the ranks. Now we have R1 as well as R2. Let us find the difference. So 6 minus 1 is 5, 8 minus 5 is 3, 1 minus 8 is minus 7, 3 minus 4 is minus 1, 2 minus 2 is 0, 4 minus 7 is minus 3, and 5 minus 6 is minus 1, 7 minus 3 is 4. Okay, so we have just subtracted these two ranks to get the value of D. So D is equal to R1 minus R2. You have to not take R2. Okay, can you all hear problem? Now we found the value of R1 minus R2. You should not find the value of R2 minus R1. Okay, keep it R1 minus R2 only. And once you find this, then you are supposed to find D square. That is, just square all these values. Okay, now the final total what is required for the computation is nothing but sigma D square. Okay, summation of all of these values is sigma D square, and the value of n, is nothing but 1, 2, 3, 4, 5, 6, 7, 8. So n is equal to 8. Okay, did you all understand the table calculation? Any doubts in the table calculation? Yes, everybody understood? Okay. Now we have to use that sigma d square and n value to find the value of rank correlation. Okay, they have given the explanation how to do the calculation here. Okay, then R is equal to 1 minus 6 into sigma d square whole divided by n cube minus n. So this is the formula for Spearman's rank correlation. So 6 into sigma d square. What is sigma d square? Sigma d square is 110. So we are going to take that sigma d square here. So 6 into sigma d square is 110 divided by the value of n, as I already told, is 8. Sorry, was it 8 or 6? 1, 2, 3, 4, 5, 6, 7. Yeah, it is 8. Okay, it's 8. So